Alright. A particle B moves along a straight line. The speed of P is T is V. Speed of P at time T is V, where V equals AT squared plus BT plus C. A, B and T are constants. The initial speed of the particle is 15 meters per second. After 2.5 seconds, the particle reaches its minimum. When you see the word minimum, that's when you know. Alright? Now, the first thing we can do here is we know its speed at a certain time, don't we? Does that make sense? We know the V value is 2.5 when the T value is 2.5. So what does that mean? This equation should fulfill that point, should it not? So what do we get here? 2.5 equals A times 2.5 squared plus B times 2.5 plus C. Okay? Do you want to divide both sides by 2.5? Actually, no, we can't do that. Never mind. So 2.5 equals, what's that, 6.25? Yeah. A plus 2.5 B plus C. Stop there, don't worry about it. Okay? Next part. It says it's a minimum, so what does that mean? First derivative must be equal to 0, because it's a turning point. So the first derivative is 2AT plus B. And we know it has to equal 0 because it's a turning point. We know the T value is 2.5, so what does that mean? Huh? 5A plus B equals 0, and B therefore equals minus 5A. I also left out a bit of information here. Initial speed is 15. What does that mean? C equals 15, because you're going to replace all the T's with 0. 0, 0, and you know that your velocity is 15. This implies C equals 15. Because you know C equals 15, you can then replace this with 15 here. We can replace the A with what? What can we replace that A with? What? Oh, we can replace the B with minus 5A. Let's move everything over to so 15, 2.5 take away 15, minus 12.5. What's 6.25 take away 12.5? I think it's 12.5A. Minus 6.25A. And then after that? A equals 2. Is that alright with you guys? Alright. Now if A equals 2, what does B equal? B will therefore equal minus 10, because it's minus 5 times 2. And C equals 15. Alright. All my previous work is pretty much not much use to me right now. Is that alright? If velocity is the original equation, which it is, velocity is the original equation, what's the first derivative? Acceleration. First derivative would be acceleration, correct? So the v dt is, what's 2at now? 2 times 2? What is it? 4t. And b? Minus 10. So that's your acceleration equation. And it wants it at t equals 4. So what's that? 16 take away 10 is 6 meters per second squared. We all good? Alrighty. The distance travelled in the third second of the motion. The third second of the motion. What have we not done yet? We haven't integrated. And next question, why haven't, so we haven't got a distance equation, do we? So what's the velocity equation as it currently stands? A is 2t squared, B? And then C? Alright, anybody care to tell me a suggestion to make for V? ds dt. V is ds dt. The change in distance over the change in time. Where do you bring that to t? Cross, alright? I have technically made a brackets mistake. What should I do on the right hand side? I should say it's all going to be integrated, right? Now here's the tricky part. What are the limits I'm going to use? It wants the distance in the third second of the motion. So t equals 3 will be my end. T equals 2 can be my start. But what do I want to do with the distance at 2? Set at 0. So you only get the difference between T3 and T2. And call that S. Is that right? So we go for 2 and 3. Oh, sorry, 3 and 2 on this side. And then over here. Anybody? S and 0. We all good? Alright. So let's do this. What do we get? T cubed, anybody? Oh, sorry, 2 over 3 cubed. Okay. Minus 5t squared. Plus 15t. From 3 to 2. Plus s from s to 0, which is just s. My lazy way of doing this is to put in the equation. So our table function, I just do 2 over 3 x cubed. I'll explain what I'm doing now. Just saves me into thrown in twice, minus 5t squared squared, and then plus 15x. Done. Start at 2, end at 3, step at 1. Anybody get 46 over 3 and 18 for the two of them? So the first one will be 46 over 3. The second one will be? Oh, was it? Oh, yeah. 18 take away 46 over 3. That's when you sub in 3 and 2. Right, what do we get down, guys? 2 point? Yeah. Alright. Now, let's begin. A particle has a mass m and falls vertically downwards under gravity at time t. The particle has a speed v and experiences a resistance force of kmv, where k is a constant. The initial speed of the particle is u. Show that v equals all of this. Alright, so to show that question, which means that the presentation is important. Is that okay? So the presentation of your answer has to be done in a specific way. So let's begin. Alright, two forces at play. What are the two forces? Mg, which is gravity, which sends you on your way down. And what's kicking it back up on the opposite direction? The resistance force. Which is? Kmv. Overall, are you falling down or falling up? Overall, I'd say you're going down, right? So, your net force is mg minus kmv. Is that right? Next thing after that is force equals what? MA. And what does that do to all the M's then? Huh? Just cancels, right? Next choice. Am I going to use V times the V dx or am I going to use the V dt? Now, why am I using the V dt? What's the key hint? Time is written everywhere, isn't it? So it's very obvious you're using the V dt. So the V dt is exactly the one you need to use. Okay. It's looking nice so far. It's not too bad. Okay. Then we're going to cross multiply the dt. We're going to take this g and kv down together. So it's going to be 1 over g minus kv dv. That thing dt. Right, what are our limits? Anything in the question to give us limits? Falls vertically. What does that mean? Falls. Velocity is 0 at time 0. It's not thrown, it falls. So? Oh crap, there it is. So unless it said that, if it says falls, it's usually 0, but initial speed is u. Fair enough. And the other thing glaring me in the head as well, which I would have spotted a couple of seconds later, was there is a u. So it must mean I have to sub in a u. Right? So call that u, call that one v, call that 0, and call that t. Now, alright, see this thing here, the 1 over a plus bx plus c? You don't have to worry about the c, why not? Has limits. C does not exist. Right, what's the next part we're going to do? What's your b value? B value is minus k. It's what comes in front of the variable. And your a value? G. So we know how to integrate this now, don't we? So here we go. So here's what we're going to get. Yeah. Alright. 1 over minus k, or minus 1 over k, is ln, the absolute value of g minus kv, equals t from t to 0. Made a mistake on the left. Anybody care to tell me? I didn't put any limits, did I? Nope. Alright. And that, I don't like having the minus on the denominator ever, so I'm just going to put it back up to the numerator. Well, good. Now let's see what we can do here. Minus 1 over k ln g minus kv. Minus minus is a, plus 1 over k ln, what's it going to be? Ku. And then equals just t. Alright, what letter does it want me to isolate? Wants v on its own. Alright, I'm thinking get rid of the k. What can I do over here? All good? First thing to get rid of. Alright. Next thing I'm going to use is what happens when you take away logs. Division is what happens when you take away logs. So I'm going to use ln g minus ku all over g minus kv equals kt. What? Oh yeah, so Mick, what's ln5 minus ln7 minus ln5? Okay. What's minus ln7 plus ln5? Same thing, right? So I just took that minus at the beginning and just did it in one step. I didn't rearrange it just to do it again. Alright, that's alright though. Right, this doesn't matter if the minus comes before the plus, it's still obeys the same rule, which would be ln, what's it, 7 over. Oh, wait. Sorry, Mick. Sorry, my bad. That's what I meant to say. Doesn't matter if the minus leads to plus. It's still ln 7 over 5 either way. Okay? My bad. Right, that's what I did there. The minus led to plus, so I just did the rule anyway. Now, let's do the e. That's base e. So bring the base up. It's e to the power of kt g minus ku over g minus kv. Alright, multiply the g minus kv there, and what do we get? G e to the. Should I do that? No, I shouldn't multiply though. Never mind. I just figured out that after I multiply it, I'm just going to have to undo it again, which isn't conducive. I think I'm going to trade positions here. I'm just going to look at the presentation of the answer. Yeah. Wants the whole thing as one fraction with the minus kt over the other side. Alrighty then. G minus ku. Yeah, I'll get there. I don't think I've made that mistake yet, Mick. I'll get to the minus kt in a second, right? It's coming. Alright? Now, cross multiply this underneath. Now, Mick, what's 1 over e to the kt? Yeah. Okay. And then bring the kv to the left and the g to the right. And what I'm hoping to get here is kv equals. Oh, then I have to bring all this over as well. No, let's keep going. Sorry, the g stays where it is. G stays where it is, right? So it's g minus g minus ku e to the minus kt. Divide by k, and what do we get? V equals, anybody? G over k minus all of this. Oh, sorry, there is no minus in the G. Thanks, Mick. Good spot. Now, problem with me doing it on the board is I keep forgetting what the answer looks like. So I'm trying to go back up and take a snapshot of it and figure out what I'm going to do with this next. Alright, so here we are. Going to bring it down. I think it's just a small thing. Why doesn't my one look like that? Okay, let's find out. Oh, yeah, it's grand. Perfect. So, see this part here? Why am I allowed to divide the two of them into each other? Any reason? They have nothing to do with the power, do they? So they can just divide into each other. So then you're going to get V equals G over K minus, open brackets, G divided by K, G over K, KU divided by K, minus U, and E to the minus KT, and you're done. Difficult. It was difficult to get it in that form. Okay, what's the next part of the question it wants from me? If U equals 9.8 and K equals 0.98, find the distance travelled by the particle in 4 seconds. Okay, hoping this is a bit easier. Alrighty. Distance travelled by the particle in 4 seconds. Ouch. Alrighty. It might be. Did anybody go through V to VDX again from the beginning? Not worth it. No. I was just thinking it's not worth it because you can just slot everything in here. Alright. Now, V is ds dt. You cool with that? So ds dt. And what we're going to do is we're going to throw in some numbers here. Are we allowed to use G as 9.8? Yeah. I don't know why we wouldn't do that. So it's 9.8 divided by 0.98, and then minus 9.8 divided by 0.98. Take away U, what's U? Also 9.8. They're being very nice here. And E and K is 0.98 to the power of 4, isn't it? We know every single value. So what does that mean we can do next? What does it mean we can do? We can throw it all into the calculator, can't we? So what happens when we throw it all into the calculator? I'll make it a bit easier on you. It's probably, that's 10. Take away 10. Take away 9.8. Oh, sorry, 10. 9.8, and what's this? What's 4 times 9.8? 3.92. 4 times 9.8? What you get is the overall answer anyway. So throw it all in the calculator in one go and tell me what you get. 39.8. Is that right? Are we cool with that? Alright. What? Oh, it's the power of minus, isn't it? Yeah, my bad. Is it still 39.8? Yeah. Oh, sorry, 39.2. Sorry, 39.8. Yeah. Alright, good. Now, you see there's a little lapse where I forgot to put the minus in. Can send you down a rabbit hole or whatever else. Now, right, we're going to cross multiply and we're going to get ds equals 39.8 dt. What's the goal of the question again? 4 seconds. So what do we do there? 0 and S and? Oh wait, sorry, no. 39.8 is the final answer, sorry. I thought we were on the final. Mick. Alright, so can anybody put that back in the calculator again? I think the answer must be 39.8 divided by 4 or something like that. So what's 39.8 divided by 4?
9 point, it's basically 10.
Yeah, this answer here?
Yeah, 9.99.
99999?
996.
Alright, so 10. Is that alright? Grand. 10. Alright. That's going to give us an answer of 40 then.
Yeah, 40 is
40 is the correct answer?
no, 40 is for one of the, so it's 40 minus 0.2. If the f equals 40 minus 0.2.
Alright. I'm going to integrate this, Mick. Can't help but think we made a decimal error, but we'll find out.
That's worked out completely
Is
different.
something else.
I'm going to get an answer 40.
Yeah, and then that's one of the answers, and you have to take point two from it, which is the other answer you get.
Alright, there's another answer.
Yeah, well, because
Oh, this error, right? So, lads, key error I made here, not you guys, I made it. See that the STT, there's a variable up here. What was the variable? What did it used to be called? T. Yeah, so we should have integrated that instead of plugging it in and then doing it that way, because there's a variable here. You don't do that if a variable is active. That's on me, my bad. So your answer there would have been wrong, oversimplified. So you would have lost a lot of marks there. So let's go back. The STT is 10. And what's this then? 10 take away 9.8, which is 2 e to the power of 0.98t. Wrap it all. That's dt. This part here is ds. Integrate it. S to 0 and what's it, 4 seconds? 4 and 0, yeah? Now, when we integrate this, we'll get a s to 0, which is s. Then we'll just get 10t. What's the rule when you integrate e?
1 over the power e to the power.
Keep the power exactly the same. And 1 divided by the derivative of the power. What's the derivative of the power?
Minus 0.9.
Is that alright? And what's 0.2 divided by 0.98? It's very close to 0.2 anyway.
10 over 49.
What?
10 over 49.
Yeah, which is essentially 0.204, but we'll use 10 over 49, okay? Plus 10 over 49, is it?
Yeah.
Yeah. Okay. Now here's what we need from you. Need you to put in 4 and 0. And 0 actually has a value, unfortunately. Let's try it this way.
Is the 10 over 49 not attached to the e?
Oh, it is, yeah. My bad. Very good. Alright. So what's it? 10 times 4 plus 10 over 49 e to the minus 98 times 4. Take away, somebody get good on the calculator with this. We're going to need it. Plus 10 over 49. What's e to the 0, isn't it? Essentially. So it's just minus 10 over 49 there. And this part here is 40 plus 10 over 49. E to the 4 times 9.8 is minus 3.92. So just that last line in the calculator will hopefully get us the correct answer. Huh?
That's 39.8.
Is it 39.8? Happy days. Okay. So what we learned, what I knew already, but we should know already, is that if they give you a variable to plug in, don't plug it in if you're using integration. You can plug in any other letter you want. If they give you a value for U and a value for K, you can use that all day long. But if they give you a value for the actual variable, which is the letter that's on the bottom or the top of the differentiation sign, do not sub it in. Put it as part of your limits. Alright, good. Alright.